Okay, so let's take a look at using our GeoGebra applications to work through the handouts for Chapter 4. The first question asks us to count the number of ways that we can form an outfit. There are 3 pairs of shoes, there's 8 shirts, and there's 2 jeans. So that gives us 48 possible outfits. The second one asks us to look at license plates. So it says that there's 10 digits for the first choice, then 2 letters, 26 each, and then 2 more digits. So that gives us 676,000 for that. Now we're looking at a permutation. So we're asked, among 210 students, how can we form the 3 offices of president, vice president, and treasurer? So 210 is n, and our r is 3. We're looking for permutation because order matters. We're not just selecting a committee of 3 students, but we are ordering those as president, vice president, treasurer. So it looks like, where's the commas there? So 9,129,120 different ways of doing that. The next question asks us to look at committees, so now we're talking about that. So we enter the number of committees that can be formed, 1,521,520, so we enter that. The next question asks, we're choosing plays from among 19 available. Looks like in the next question we're asked about the order, but in this one there is no question of order. So n is 19, and we're going to put on from among those 19 plays 5 of them. And we're saying that order doesn't matter, so it looks like 1,000, or actually 11,628 different possible playbills. Now if we look at the order in which they're presented, now we're talking about permutations. So we enter the 5 factorial. So if we want 5 factorial, we need to change that to 5, and it will give us that 5 factorial for our n. And if we want to know how many different ways those can be presented, we could choose 5, choose 5, which is also, or 5 with the number of permutations, 120 again. When we're interested in ordering things or arranging things, we're using combinations. So when we arrange identical things. So in this next question, it asks us how many ways are there to arrange exactly 3 ones in an 8-digit binary number. So all the other digits would be 0. So R is 3, because we're interested in our 3 zeros, and n is 8. And remember, these ones are identical things, so we're looking for a combination. So it looks like there's 56 ways of doing that. In a week, that's 7 days. How many ways can it rain on 3 days? Again, we're assuming that those 3 rainy days are identical. So now n is 7, and we're looking at 210 ways, combinations. We're looking at 35 ways that can happen. 3 deluxe model homes and 5 standard model homes be arranged. So there's 8 homes total. And we can either ask the question for 3 or 5. So I'm going to leave a 5 there. Notice that that's 56. If I change R to 5, it's still 56 because we're arranging the same items. So we're going to give our special pet some birthday presents. It looks like there's 1, 2, 3 presents, so R equals 3. And we're going to do that over the course of the week, giving your pet these surprise gifts with no more than 1 gift each day. Now, the interesting thing here, of course, is that we were told that these gifts are different, bone, collar, and ball. So when we work through this, this is actually a permutation, and so we've got our 210 there. The next question asks us to toss a fair coin and count the number of ways that you can get exactly 0 tails. So again, we're arranging identical things. We're arranging tails among tosses, the rest of them, of course, being heads. So we can go through and do this rather quickly. We can say among 7 tosses, clearly there's only one way that we get 0 tails, and so we're now moving on to 1. Now there's 7 ways, and 2, and we can see that there are 21 ways. Remember, we're looking at combinations here. We're saying that the order among those 2 tails in this case doesn't matter. Now when we add these up, you'll say, well, what is that going to be? Well, we already know exactly what it's going to be. It's on our screen, 2 to the 7th. So 2 to the 7th in our calculator, let's get that back up. 2 and then raised to the 7th power, 128. In how many ways can you toss a coin 7 times and have 3 tails? Now it's asking us to look at this table, and that's of course getting exactly 3 tails among 7 tosses. In how many ways can you toss a coin 7 times and have 3 or 4 tails? Now we're going to add up the 3's with the 4's, that's 2 35s or 70. In how many ways can you toss a coin 7 times and have less than 7 tails? Now you might say, well, that means that we have to add up all of these, but once we know that we're interested in everything, that is 128, except the one case in which there's 7 tails, we can simply do the arithmetic. All the cases take away the one case that we're not interested in. So very similar in this next question, how many ways can you toss a coin 15 times and have at most 14 tails? So the first thing we want to do is count that total again. We want to know how many different ways are there of tossing a coin 15 times. So let's pull up our calculator again. So 2, and we're going to raise that to the 15th power. But we're interested in everything but the case where there's 15 tails. So that only happens one way. So we subtract 1, and that gives us our answer. Let's delete that. And that gives us our answer, 32,767.